Hello, everyone, and welcome to the OpenMind's first AMA of the year 2020. Ask Me Anything questions. Well, OpenMind is an open source community focused on making the world more privacy preserving by lowering the barrier to enter the private AI technologies. In the AMA interview, you'll have the opportunity to ask questions of privacy experts from open community. My name is Amel Salemi, and I'm from SPAX. I'm your host for today. I'm an AI engineer working at a company named Instady. First, we're going to have two amazing people with us today. Andrew, the leader of OpenMind, is going to talk about OpenMind a little bit and of our New Year resolution before carrying on with our schedule for today with Ionesio. So, hello, Andrew.
Hi, Emil. Good to see you.
Good to see you too. Do you have anything to share with us about OpenMind?
Yeah. So, what I'd like to share today is a bit about our plans for 2020 for the year. So, we have sort of one high-level theme as a community that we're going to pursue, and I hope that by sort of just presenting it real quick, that will help people who are watching the call understand how they can get involved in our various projects and initiatives. So the first thing that I kind of like to share is actually our new roadmap section. So I'm going to share my screen here on GitHub. And what you can see is inside of this new repository, so OpenMind/roadmap. So you can see up here in the URL. That's a little bit small. Each individual team within OpenMind has articulated the different roadmaps that they would like to pursue over the next 3 to 6 months. But the first thing I'd like to call your attention to is actually the general OpenMind 2020 roadmap. And so you might be familiar with our mission statement already, which is to make the world more privacy preserving by lowering the barrier to entry to privacy preserving technologies through open source software and education, right? So in short, we write code that's free and we do free education like courses and tutorials to make it really easy to preserve privacy. But in 2020, we have a sort of more targeted refinement of this mission statement, which is that we want to solve real privacy problems in production and lower the barrier to entry for others to do so through software and education. And the reason we want to highlight in production this year is that while over the last 2.5 years, we've been writing lots of great software, in my experience, there's a certain delta between what you write when you think you understand what people want and what kind of code you write when you're actually helping someone to put it into production. There's kind of this last mile effect of the last features that you need to be able to put something, deploy it at scale for real users. And so the goal for this year is to take a lot of the sort of use cases and prototypes and toy examples that we refined in particularly in PySift and PyGrid over the last 2 years, and help actual organizations put them into production, and in doing so, really harden our code base and really finish those last little bits and features, things like packaging and security and performance that people actually need to be able to deploy this in the real world. So you'll find in this document that there are specific production deployments that we actually want to do. So the first group are sort of what we call enterprise platform use cases. So the first one is around cross-organization model evaluation. So we would like to partner with a use case partner, so an actual enterprise that wants to be able to evaluate a model inside of another enterprise, right, in sort of a privacy-preserving way. The second enterprise is cross-organization federated learning. So this year, we would like to help several different organizations train an AI model using data that's distributed across the organizations using federated learning, right? So as you can imagine here, this involves several different development teams that would come together to help what we call a use case partner, which is someone who wants to do federated learning, actually deploy it into production. So there are 3 different groups of use cases. We have enterprise platform use cases, we have smartphone platform use cases, and then we have open research platform use cases. So as you can imagine, enterprise platform use cases are use cases targeted towards sort of existing enterprises and businesses that have some use for privacy preserving machine learning, right? So we want to help sort of existing businesses be able to deploy this. Smartphone use cases have to do with deploying this in the context of a smartphone app. So you'll find that the various use cases in here, one being federated learning with secure aggregation, and the other one being consumer selected on-device ML, so it's basically on-device prediction. These use cases have more to do with there's some startup or company that has a smartphone app, and now they want to do some either on-device prediction or federated learning focused use case within the context of their existing smartphone application. And then the third group are sort of these open research platform use cases. So there's really two here. I won't go too deep into them at the moment. And you'll see that the descriptions for these different use cases will continue to be filled out as we sort of refine features and refine requirements and partner with existing organizations on their execution. Obviously, OpenMined as a community is an open source group, primarily made up of volunteers, but also recipients of various grants. And while we are still, unincorporated as an organization, we really feel that it is our duty to further lower the barrier to entry to privacy-preserving machine learning by assisting existing entities in their desire to use our software. Now, there is one sort of pit stop I'd like to take before finishing up this kind of overview, and it's to hop into what some of these sort of what some of these individual team roadmaps look like. So if you're curious about sort of what's going on in OpenMined, here are all the different groups that are doing something every week inside of the OpenMined community. And if we click into one of these folders, we'll see that each project has kind of two subfolders. One is meetings, and this is sort of the week-to-week meeting notes, including what we plan to build that week, what this team plans to build that week, which you can obviously click into and take a look at. So this has sort of several individuals and the things they worked on last week and what they're planning to work on next week. And then we also have high-level project descriptions. So if we click into federated learning, for example, this is the main project description for the federated learning for mobile project. So this is one of the projects that's sponsored by the generous grant from the PyTorch organization. And in here, you'll see basically the next 3 to 6 months of development. And so if you're interested in jumping into kind of an existing project, and maybe you're looking at GitHub issues online, maybe you're watching pull requests come through and you're like, man, what's like the big high level thing that's going on here? Like what's the bigger project, and where could I potentially try to jump in? That's what these documents are designed to help with, is like giving you an overview for kind of the 3 to 6 month roadmap for this long-term project. And you can see similar projects inside of these various team folders. And this includes both development teams and what we call community teams. So for example, like the social media team is a community team focused on curating OpenMined social media presence, right? Or the writing team is focused on producing lots of blogs and articles each week about various parts of our roadmap. So with that, I hope that this makes a bit of sense. So just to recap, like the goal of our community for the year is to put things into production, right? And the reason that we want to put things into production is because our mission is to lower the barrier to entry to privacy-preserving machine learning. And while, of course, we've done lots of great work so far, actually helping people put it into production the first time and really, polishing the last little bits of our code base to make that easy to do, right? By going through it ourselves, I really feel it's just going to really pave the way for other people to go behind us and further deploy these production deployments. And you'll see the themes for these use cases that we're interested in. Every single one of these use cases is not the kind of use case that just one company or enterprise or startup or nonprofit would ever pursue, right? Each of these is just one example of a category of use cases that we want people to use our software for. And so by us helping to do it at least once, we can then sort of speak from experience when we're saying, okay, here's how you use these various libraries that we're constructing to be able to implement these use cases. So I hope you find this is interesting, and I hope that you will consider jumping into development here at OpenMined. Obviously, if you need help, apply to have a mentor. If you're not sure where to get started after having worked with a mentor, jump into some of the learning resources. So the Udacity course on secure and private AI is still taking students. If you feel that you understand the basics of privacy-preserving machine learning, but you're not sure where to get involved in development, go on GitHub and look for GitHub issues that are marked good first issue, because anything marked good first issue is designed to be the type of issue that someone could do if it was their first project inside of OpenMined, right? And of course, once you've completed your first issue, then you're ready to apply for one of these development teams. So scroll through the roadmaps page, look at all the different projects the different teams are working on, and figure out which team you think is the best fit for you. Would you rather do sort of mobile development and work on some of the the Android or iOS software that's happening, or were you interested more in maybe server style architecture? So working on like maybe the PyGrid team. Or if you're interested in more kind of algorithm design, then maybe you'd want to join the cryptography team, which is focusing on implementing new and faster protocols in secure multi-party computation and homomorphic encryption and things like this. So I hope that or if you want to do sort of more sort of public-facing things, then join the writing team, and you can work on everything from blog posts to papers. And also documentation, like, and supporting a lot of the other development. So I hope that you'll find that we have a variety of groups here that you can get involved in, that you can make friends and have lots of fun while helping us fulfill what I think is a really awesome mission for 2020. So thanks a bunch, Mel.
Yeah, great. Thank you very much, Andrew, for being with us today. Actually, I hope 2020 will be a great year for protection, for privacy preserving machine learning and everything else. Next, we're going to be with the amazing Ionesio, who is joining us today. He's an AI researcher supported by the OpenMined RAAIS Grant program. As the leader of the PyGrid team, he works to build a peer-to-peer platform for private data science and federated learning. Welcome, Ionesio.
Thank you. I'm great to be there.
Great. Thank you for joining us. Welcome. Ionesio, we have more than 15 questions submitted beforehand for you to answer. But in the first 20 minutes or so, we're going to dive in the technical part of the PyGrid, of course, with a little bit later a demo, and then we're going to answer these questions. So are you ready?
Yeah.
Okay, let's do it.
Let's do this. So should I share my screen?
Yeah.
Oh, awesome. Okay, let me just, whoa. Can you see it?
No.
And no. Okay, I need.
Okay, cool.
Awesome. So, okay. Welcome, everyone. Today I will talk about PyGrid, which is a platform for privacy preserving in data science. For privacy preserving data science for machine learning. And before I get started, I would like to thank our sponsors. So this project was founded by RAAIS Foundation and commissioned by Oxford University and the United Nations Privacy Test team. So thank you. And over the next few minutes, we'll be discussing about 4 main topics. First, we need to understand the basic concepts to figure out the PyGrid purpose, like federated learning and secure multi-party computation. And after discussing about these topics, we need to understand the PyGrid and PySift difference. So we need to explore the PySift library and the PyGrid platform. And in the third section of this talk, I will show some practical examples using PyGrid. These examples will help us to understand the PyGrid architecture and figure out how it works, how it can be applied to real problems. And finally, we can finish our discussion by talking about the PyGrid roadmap for 2020. So cool. Let's get started.
Interesting.
Okay. Yeah. So the first concept that we need to learn is about federated learning. So federated learning is a technique which allows AI model to learn without the users having to give up their data. So let's walk through about the federated learning process. So the first step is basically create an initial model. Here we have the AI incorporated company, and the AI incorporated company needs to send this initial model to someone's device, in this case, Joe's device. So this model will be updated and trained by Joe's data. And after the training, the Joe will return the updated model to AI incorporated. And this model will be sent to another device, in this case, Jane's data. which will be trained using Jane's datasets, and we will repeat the process, send it back to the AI Incorporated, and we can basically perform this process over all nodes connected to AI Incorporated. So that way we can learn with Joe's, Jane's, and Jack's data, and that's basically how federated learning works. Here we have some benefits of federated learning. Federated learning increases privacy of sensitive data, because instead of send users' data, we are sending only models. So it reduces the legal liability for the model owners, because the AI companies doesn't need to handle with users' data. And also it reduces the network bandwidth involved in uploading huge data sets, because the AI companies doesn't need to upload a lot of data sets to train a model in a centralized way. So, and also we have great examples, like a data scientist training on data from multiple hospitals. We can think about a model to predict breast cancer that will use different data samples across countries. And also we have a smartphone app getting smarter by training on data from multiple phones. And at least we have like an automobile company learning to predict when its cars will need to maintenance by training models across a fleet of cars. So it's a great feature.
Yeah.
And also we have we need to understand what exactly is secure multi-party computation. Secure multi-party computation is basically a different way to encrypt data, sharing it with different devices. The great advantage of this technique is basically because it allows us to perform logic and arithmetic operations using the encrypted data. So here is an example showing how it works. Here we have the Andrew face. He's holding the number 5, his personal data, and he can basically anonymize his data, decomposing into 2 or more numbers. In this case, he's decomposing the number 5 into 2 and 3. So, and also he can share the anonymized data with his friends, in this case, Marianne and Bob, and none of them really knows the real value of Andrew's data, because they are holding on a part of it. So, but an interesting fact is the number can only be used if everyone's agree. So if Bob tries to compute an arithmetic operations using the number 3, and Marianne disagrees with it, the MPC protocol will not work. So everyone needs to agree with the use. As we can see here, we are basically, all of them are forming a multiplication, an arithmetic computation on anonymized data. And as we can see, we can achieve the same result as we would multiply the number 5 by 2, basically. So federated learning, secure multi-party computation is a great feature to privacy preserving, because we can encrypt the models, protecting the company's intellectual property, and at the same time we can use secure multi-party computation to protect the user's privacy. So as we understood the basic concept, now we need to figure out what exactly is PySift and PyGrid. We need to understand the difference between them. So PySift was built to be a Python library for private and secure deep learning. PySift aims to provide privacy-preserving tools within the most famous deep learning frameworks like PyTorch and TensorFlow. And that way, the data scientists can use this framework to run, to handle with any kind of sensitive data, applying privacy-preserving concept in a high abstraction level. And PyGrid is basically a peer-to-peer platform that uses PySift and tries to provide a secure way to perform data science and federated learning. PyGrid is composed by basically 2 components. We have the gateway, which works like a DNS server, and we can use the gateway to perform queries over the network. And as a data scientist, we can use the gateway as an interface between the data scientist and the grid network. And we also have the nodes. The nodes are provided by the data owners. So each node has his own data owner. So, and we can attach different types of devices and apps. So if you think about a smart home context, we can think like a grid node as a smart home assistant, and we can attach IoT devices to populate this node with data. So, and also the data owner have total control to allow or deny access to their data. So it's a great way to empower the data owner with the power to control their own data. And now we need to understand how does it work. So we have some use case here. The first one is basically about private statistical analysis. So in this use case, we have basically two perspectives. As a data owner that wants to publish his sensitive data on his node, and also as a data scientist that wants to use the PyGrid network to perform queries, searching by the desired data set, and to perform some statistical analysis. So basically, the first step as a data owner is import the dependencies. So we need to import Sift and Torch, and we need to replace the standard Torch models by Sift Torch hook. And as a data owner, we need to know previously the node's address, because this node was deployed on the data owner infrastructure. So in this case, we have the hospital data cluster. And also, this is basically the data that we want to publish. So in this case, to give a clear understanding about the data that we want to publish, we need to provide a brief description about the data meaning and a brief description about how the data looks like about the data structure. So in this case, we have the month birth records of the month of February. And as we can see here, the first column represents the gender, and the second column represents the weight, and the third column represents the height. So, and also as a data owner, we need to be able to allow or deny the access to some data set. So here we have an example showing how to allow some users to get access to the real values of this data. In this case, we are allowing Bob and Alice to get the access to the data. And to turn our data accessible to queries, we need to tag and label them. So in this case, we are tagging this data set with two tags, basically. February, which is basically the month, and birth records, which is basically the data meaning. And as we did this, our data is ready to be published. So we can just send the data to the grid node. But it's important to observe that to publish a private data into the node, you need to authenticate, and you need to be allowed to do it. So that's all we need to do as a data owner. So it's basically the pipeline for populate the grid nodes. And also we have the perspective of the data scientist, which is basically the same thing in the first step. But instead of connect directly with the grid node, as a data scientist, we need to be connected with the grid network, because as a data scientist, I'm not supposed to know how many nodes we have in the grid network and where exactly the data lives. So I need to perform queries to discover. And in this case, I'm searching by the tags that we used before. In this case, February and birth records. And as we can see, the grid network found the hospital data cluster as a host, and we have our remote pointer. And in this instruction, we are basically defining a direct reference to this remote pointer, just because we received a dictionary, so we need to work with the remote pointer directly. And as a data scientist, we can explore the description to understand how the data looks like and to understand how can we use it. So, and here we have an example showing what happens if we try to retrieve the value, the real values of the data without being allowed. So, if we don't provide the credentials, an exception will be raised. So in this case, we get the get not permitted error, but we are still able to perform remote computations. So in this case, as we can compute the average of the height and the average of the weight, so we need to sum the columns, and that's exactly what this function do. We are basically sum the columns remotely, and we can use this function to compute the weight sum remotely, which will return a different pointer to us, and we can do basically the same thing with the height. And also, now we can retrieve the value, the aggregated value, using our credential. In this case, we are using the Bob's credential, and basically divide this value by 5, which is basically the data size. And we can basically do the same thing with the average height, with the average height. So that's all we need to do as a data scientist, and we were able to compute private statistical analysis. It's simple, but it shows the power of the platform. And
this is amazing. This is amazing. Yeah, it shows how powerful the tool is to build life for data scientists and all. Yeah. Amazing.
Yeah. So as a data owner, it's a good question. Think about how can we manage the data access. So this feature, it wasn't implemented yet, but we intend to provide an user interface to manage different accounts on grid nodes. So as a data owner, I can identify the users that are using my grid node, and I can allow or deny access to the data request. So, and also we want to provide a data request queue, which is basically a technique to empower the data owner to evaluate the data requests. So in this case, we can evaluate the data requests made by a lot of people, and we can evaluate the privacy budget left, and what's the privacy budget requested, and what's exactly is the value of the sensitive data. So, and we can also allow or deny this access. And I believe it's a great feature to be implemented in this year.
Yeah,
and
should be.
Yeah. So in our second use case, we have the cross-silo federated learning approach. In this use case, we use the MNIST dataset, but the process to populate the nodes with the MNIST dataset is basically the same that we did before. So I will skip this process. I will just focus on the federated process by itself. Okay. So the first step is basically import our dependencies. And for sure, we need to define our model and set up the configurations. So in this step, we are not doing something different from the standard storage. And finally, we need to connect with the grid network. And also, we need to perform queries, searching by the MNIST datasets. In this case, we performed 2 queries. The first one is basically searching by #X datasets, and the second one was basically searching for the labels. So in this case, we found 4 different nodes that are hosting MNIST dataset. The first one is Bob, Grid node. The second one is AI company, and the third one is university, and we have also the AI research lab. All of them are managed by different data owners, and we have the same structure with the target. So here we are basically defining a direct reference to these remote pointers because we received a dictionary, so we need to work with the remote pointers. And this function is actually an auxiliary function that will help us to understand how the federated learning process works on PyGrid. So finally, we have the train function, which is pretty similar with the standard torch function to train, but we have a couple of instructions that deserves a highlight. One of them are basically the model.send. Here, this function will send our current model to a remote worker, and this remote worker will train and update the model using his datasets. And we also have the function named model.get, which will retrieve the updated model, and which will use this updated model to update the global model. So as we can see here, the federated learning process goes through all nodes that host the MNIST dataset. So the first epoch, we need to visit Bob device, and after get the updated model from Bob, we need to visit the AI company device, and we need to keep this, we need to perform this process over and over again.
Nice.
Yeah.
Amazing. Yeah.
And the third use case, personally, I like so much about this use case because we try to protect the company's intellectual property and the user's privacy at the same time. So this use case is about encrypt models and run encrypted inferences on encrypted user data. So, but before we start to talk about this use case, we need to get a brief overview about what exactly is SIFT plans. So SIFT plans are basically a data structure used to execute remote, store and execute a set of instructions. So we can define a model, and we can define a model using plans and execute this model in a remote way. And also we can use the model parameters as a pointers, as a SIFT pointers. So it allows to execute a model in an encrypted way. We can basically form the multi-party computation protocol using the model weights and use the PySIFT interface to control these pointers.
Cool.
Yeah. So as a model owner, we just need to import our dependencies. But here it's important to observe that we need to set this flag to false, because the SIFT structure needs to save the plans metadata. So the next step is basically connect with the grid network. And here we defined a toy model. It's pretty simple. It's just to understand how it works. It's important to note that the net class is extending the SIFT plan. So we are defining our model by using the SIFT plans. And here we have the input value that will be used to run an inference. So, and here we finally initialize the model. And just to compare, we initialize an decrypted model as well. And also we have the model.build, which will basically serialize and create a structure of the plan and allow us to execute this model as a plan, and allow us to execute in a remote worker. So finally, we can serve this model, and it's important to set this flag to true. This flag is basically will allow us to get the model parameters and apply the multi-party computation protocol on the parameters and distribute the MPC values over different nodes, which will encrypt our model. And this function is basically to show how the model will be stored. So in the first grid node are basically storing the plan structure, and the hospital data cluster and the public data cluster, both of them are hosting the MPC values of the parameters. And also we have the last one, the university data cluster, which is basically the crypto provider, which allows to perform operations like multi-party computation and multiplication. And finally, we can run remote inferences using this model. This function, we have a lot of things happening in this function. So the first one is basically the notebook will perform a query searching by the model ID. Mm-hmm. So if we found the model ID, we need to split the input value using the same machines that the model parameters are. So we need to apply the MPC protocol in the input value as well. And after all the MPC values are distributed over the grid nodes, we can execute the plan that was stored in the company data cluster. So as you can see here, the result will return 110. And if we try to run inference on the encrypted model, we'll get the same result.
Amazing.
Yeah.
Yeah.
So, oh, sorry. Can you?
Yeah. Just saying that's what we are looking for. Like.
Ah, okay.
Yeah.
Yeah. So our upcoming challenges for 2020 is basically create an heterogeneous network, because we have a lot of different applications on OpenMined community. We want to run federated learning and PySift on web browsers and also in mobile devices. But nowadays PyGrid is a server-based application, is a server-based platform. So it would be great if we can extend the PyGrid features to browsers and devices. But we also want to implement a differential privacy feature, like privacy budget, to control the anonymization level of the datasets, and also automatic differential privacy tracking. And finally, we'll be able to implement the data request queue that was mentioned before, and it's basically what we plan to do in the next 6 months, probably.
Yeah, hopefully, lots of work.
Yeah. So thank you for the OpenMined community. I hope you enjoyed it. So
yeah, that was amazing. It's really interesting to know all these kind of things and all of these new things. So right now we're going for the OpenMined. We're going to have the OpenMined questions, and so first of all, okay, so one of the things that after this incredible presentation by Ionesio, he talked about everything like PyGrid and all these kind of things. And now we're going to go for the OpenMined AMA. First of all, we're having questions, and these questions are directed to the PyGrid team, Ionesio, and anything related to machine learning and AI. So first of thing, if we can start, are you ready, Ionesio?
Yeah.
Okay, cool. So first question is how to get started contributing as a beginner in PyGrid. Do you have any recommendations?
Yeah. As Andrew mentioned before, you can check the issues, the issues in the PyGrid repository, and also if you have some doubt or some trouble to execute some issue, to solve some issue, you can basically ask to our community. I personally would love to help anyone. So it's a good start to we just need to be proactive and try to contribute with the platform. So it's not so problematic. You just need to check and try to fix some feature.
Cool. Yeah, that's really great. I hope more people join the team. And the next question, yeah, the next question is, how do you think the healthcare industry will react and adopt OpenMined? This is asked by Andrew, actually.
Yeah, it's an awesome question.
Yeah.
Basically, nowadays we have a lot of researchers that are blocked by because we are not able to use sensitive data in healthcare system. So if we can, so if we can use the sensitive data in a secure and private way, I believe we'll have we can unblock a lot of research issues, which will probably increase the accuracy and which will open the research in the healthcare system.
Yeah, I totally agree.
Yeah.
Yeah, cool. And another question is, why is PyGrid needed and not just sockets such as WebSockets or similar?
It's also a great question.
Yeah.
Basically, if we try to use just WebSockets, as a data scientist, we are not supposed to know where the node's address. So if we try to perform queries over the platform with only sockets, we will not be able to do it because we are not supposed to know the node's address. So the platform is very useful because as a data scientist, I really don't know. I really don't need to know the node's address in advance. Do you know what I mean?
Yeah. Yeah. Totally. Cool. So another question, interesting. So when do you expect the first release?
It's okay. I hope over the next 6 months we want to develop and to release the unstable version, but we still need to form some tests like a pen test to check and verify vulnerabilities. So I hope in 6 months, but I believe at the final of this year, we'll be able to deliver a great platform, optimized platform in a secure way. So yeah.
Hopefully.
Yeah.
Yeah. Question is, why WebSockets?
Okay. Okay. Using HTTP protocols, it's quite how can I say? Using HTTP sockets, you need to basically perform the TCP protocol every time that you do a request. But using WebSockets, the WebSocket protocol, we can create a connection, and we don't need to be careful about the TCP protocol to form the TCP protocol over and over again, which is awesome because our platform needs to perform multiple operations across the different devices. So yeah, it's basically a performance issue. So we'll not be able to perform in the fastest way if we use the HTTP protocols.
Okay, seems very fair. Another question: is there any alternatives for federated learning?
I believe it depends of your use case. In computer science, there are no silver bullets, so we don't have the perfect solution for everything. But we can use page, we can use differential privacy. It depends of your need. Also, the federated learning by itself doesn't solve the privacy problems. So as we solve for the federated learning, expose the model weight, which is very dangerous because the AI company intellectual property would be hurt. So we need to think about the use case and try to adjust by our needs.
Exactly, it depends on the need.
Yeah.
Yeah, cool. And another question is, what are the top 3 tips for leadership as you are leading the PyGrid team?
I want to know as well. Actually, I'm learning about it, but I believe as a team lead, you just need to be committed and listen your friends and partners and try to understand what they need and what are basically his problems, and also keep them motivated, keep you motivated. So it's enough.
Yeah. Thank you. And what inspires you in the OpenMined community?
First, the motivation. As we said before, if we can do what we want to do, it will be great in healthcare system. So we can help a lot of people, we can save a lot of lives. And also, the OpenMined community is open, and the environment of the OpenMined is very healthy. And oh man, I learned so much with the OpenMined, and I had the opportunity to work with great people. And yeah, so all of these things inspired me to work with OpenMined.
Cool, yeah. And I think probably a question is, the system is so safety critical because of the domains it appealed, like healthcare. What is the weakest link in PyGrid in terms of compromising user privacy?
Nowadays?
So the system is so safety critical because of the domains it is applied to, like healthcare. What is the weakest link in PyGrid in terms of compromising user privacy?
Okay, nowadays, I guess it's basically the federated learning process by itself. If we not be careful about how it will work, for sure, the malicious agent will not be able to get the user's data, but he can get how can I say, an intermediary model, and with some malicious inferences and an adversarial attack, he'll be able to infer like bias in your data, and he'll probably be able to discover your behavior or your bias.
Yeah, cool. Another question is, what are your tips for the machine learning complete beginner?
Okay, I started watching the Indra's NG course into the Coursera, which is great because gives me a solid knowledge in math, and also I try to apply the knowledge that I get on different use cases. And yeah, it's just to be proactive and try to apply your knowledge on something to solve some problem.
Okay, nice. Seems very nice. Thank you, Ionesio, for your time and your efforts. The presentation was amazing. It was really helpful and really insightful.
Yeah.
Thank you for joining us today, ladies and gentlemen, and for hopefully seeing you next month for another OpenMined new AMA. See you on Slack. Bye, everyone.
Yeah. Bye bye.
Bye.